Hey everyone, today we're going to be talking about forces. So here's the situation I want you to imagine. It's 3:15, the bell rings, you're ready to go home. So you hit that door running. So let's look at the action of you actually hitting the door. And that's supposed to be a door right there. Play along. So you take your hand and you push on the door. That push is one of these forces that we want to learn about. So first, let's get a definition for force. Force is really just a push or a pull. And notice that this has, anytime it's a push or a pull, there have to be two things involved, because anytime you push, there has to be something doing the pushing and something getting pushed. Likewise, with a pull, there has to be something pulling and something getting pulled. So what this boils down to is that every force must be between two things and only two things. Never more, never less. So this force would be between the hand and the door. It's an interaction between those two. So a force isn't like an object or anything. It's an interaction between two objects. So here we see this force drawn as an arrow, and what we're going to look at next is how we name these forces and describe them. And you can see I've put this kind of cryptic message up here. You see a capital F that's in bold. That capital F means we're representing a force, and the fact that it's in bold means that it's a vector. Forces must have a size and a direction. So you can see this arrow kind of takes care of both of those. The longer the arrow is, the bigger the force, and the arrow points in whatever direction the force is going. Alright, now let's talk about all this stuff underneath here. Force, kind, on, victim, by agent, what's going on here. Anytime we have one of these forces, we describe it using a subscript, that is small writing just below the level of the other writing, that describes what's going on. So in this case, we put our letter F representing force, and then we describe the kind of force, what the force is acting on, and who caused the force. Because remember, a force is an interaction. We have to have these two things. So let's put this together piece by piece for the example of your hand and the door. So first, what kind of force is this? This is a normal force. We'll talk more about that in a minute. Just kind of roll with it for now. What is this force acting on? Well, it's acting on the door. So we say this is the normal force on the door, and it's caused by you trying to get home as the bell rings. So next, let's look at kinds of forces. So the types of forces we're going to be dealing with in this class. The first two that we're going to talk about are really the most important. The others are almost just special cases of these two types of force. So if you get the first two, you've got the big idea. However, I do want you to know these specialized names so that if they do come up, you're not going to be completely lost. You'll know what we're talking about. So the first is a normal force, and that's the kind of force we just talked about there. We said the force on the door was a normal force. And that normal, don't think that means normal as in ordinary. Normal in this case has a mathematical meaning, and it means that they occur at right angles. They're perpendicular to each other. So we have to figure out what's perpendicular here. So a normal force is a force that occurs when two objects touch. So every time two objects touch, there's always a normal force. And that force occurs at right angles to the surfaces that are touching. So here you can see that this force is at a right angle to the surface of the door. Now, normal forces are going to occur on both. The door is getting touched, so there's a normal force, but at the same time, the hand is getting touched, and there's a normal force on the hand as well that is occurring perpendicular to that surface. Now, if I keep saying perpendicular and that's kind of got you down, maybe you're kind of wondering what that means. Perpendicular just means that two things are at right angles, 90-degree angle. So there's always going to be an L shape in between the normal force and the surface the normal force is coming from. Now, one thing that makes this seemingly more complicated is what happens when these are not nice, neat angles. So let's look, in this case, we've got a car and it's parked on a hill. Now, the car and the hill are touching, so there's going to be a normal force that happens at a 90-degree angle. Remember, that's what normal means. So at a 90-degree angle to the car and to the surface. So if we add that vector in there, this is what it looks like. Notice it's pointed up and to the right, perpendicular to that surface. Again, perpendicular just means 90-degree angle, so it's going to make an L with that. All right, next up we have the friction force. And friction is going to occur when you have an object touching another object. I know it's not quite touching, but pretend it is. So we have the car touching the road, and the car is moving. They're moving relative to one another. It actually doesn't matter which one's moving at all. And the car is moving in this direction, so to your left, and there's going to be friction between them. So friction is a force that occurs when two objects are touching and they're in relative motion. So one of them is moving relative to the other one. And this force of friction always occurs in the opposite direction of the motion of the object. So if the car is driving this way, the force of friction acts in that opposite direction. And here you can see we've labeled this. This is the force of friction on the car by the ground. Again, a force has to be an interaction between just two things. All right, very quickly I'm going to throw some other types of forces at you. We have anytime you have a rope or a chain or anything like that, anything that's kind of loose, anything that you can pull but you can't push, we call that kind of force a tension force. We also have specialized forces that we look at for things like aircraft. So in this case, the engines are causing a force that is pushing the aircraft towards the front. We call that thrust. At the same time, there's friction between the plane and the air. That force is called drag, and it acts in the opposite direction. There's also a force that comes from the shape of these wings and the motion of the craft through the air that's an upward force, and we call that force lift. Now in a different scenario where we have something floating, you'll have an upward force as well. We call that a buoyant force. So keep your eye out for all these different types, but remember the two most important types that we're looking for are normal forces and friction forces, and that a force is very simply just a push or a pull.